Okay, so the first thing I'm going to do is just show you guys a little bit about how you do the file input-output in Java. Basically what you're going to be thinking about here, I'm going to give you some key classes and some of their methods that you can look up. So import these packages for input-output and the utilities we'll use on them. And the file class is probably the first one that you'll get to learn a little bit about. It wraps up a lot of the input-output functions you need to do. And here's a short list, but by now you all know how to look up your documentation to see if there's other things you want to look up. Okay. Just a reminder about the try-catch block. Because you're working on a file, you can't just ask for it. You have to try to open a file and then catch it in case there's an error. It is possible that somebody does something wrong in that process. So here's an example of the way it's declared, just so you know the guts that are working underneath the try-catch block. Is if you declare a method that can throw some form of exception. This is a key word in Java, throws. It tells the compiler that no one can use this method without a try-catch block. So if you want to force that behavior upon someone who uses your code, that's how you do it. You tell Java this can throw an exception. So this is kind of I wouldn't say a bad, but a trivial example. If I'm saying this must be an odd integer you give me, one thing I could do is just ignore it, right? I could just say, uh-oh, they didn't give me the right data. Otherwise, if it's not an odd number they gave me, I could throw an exception. And this is a pretty terrible exception to throw. You would want to build an exception, one which provides more information to that person about why there was an error. So if you throw a generic exception, it's not going to give any specific way of figuring out what went wrong. So you'd like to build an exception with more information. You can probably see like array index out of bounds exception. What else might you have seen? You know, stack overflow, like different exceptions that get thrown up that are more specific in Java. Maybe you use a negative number when you use substring on a string. I mean, there's different ways that you might get an exception thrown. But if it survives that exception, then you would go on as normal, and that's you doing the error checking. So that's how it happens in Java, the keywords, if it throws an exception and where you throw it. But your job as the programmer using that code is to do a try-catch block. So just as a quick refresher here, I'll show you what one of those looks like. So in your code here, if I try to create a file, that's fine. However, it might not work. This may be a file which is invalid. It may be that when I try to do something, an error happens. So here is where I'm going to now try to read from the file, do some magic with it, do a little bit of reading to it, and then when I'm done, I'll close the file. So if everything went as planned, it executes like normal. But when something is a problem that's thrown, this is where it's going to happen. It's an I/O exception. There are more specific forms of exceptions, but that is the top of the class hierarchy, is an I/O exception for file readers. So there's definitely more than one way to do the reading. I don't really recommend this. This is fast, but it tends to hog resources, which can then make it slow. Basically, every time you ask the hard disk to read, it has to go and look up the file. So that takes a lot of time in the lookup and then in the extraction of that information off the file. So if you do it all in one shot, that's fast, but again, it hogs a lot of resources from the system. So this is how you could do it. One possible way of reading a file is you give it an array, and the file will, by calling read, it will stick as many characters as it can into that array. So and then you can manipulate your file by looking through each character in that array. So that's one possible way of doing it. You can have a look at the reading partial arrays as well. This is typically the way it's done, is you tell me where to start putting the data and how much data you want, and you keep calling this method until you get to the end of the file. So file readers are great. I suggest you have a look at those. We are going to take a look at how the scanner is going to simplify that process greatly for us too. So that's why I'm skimming this one, is a file reader can be wrapped into a scanner, and you already worked with scanners. So that's why I'm kind of skimming here. Similarly, a file writer has a lot of methods that are going to be helpful to you. You can take a look at some of those examples. Same problems can happen. It needs a try-catch block. If there's no file there, that means you need to try to do it before you actually assume it's going to be executed. So these are the two classes then in the utilities package that wrap those things and make it much friendlier to work on. So let's take a look at how scanner you know this class. So the same way that you would normally do a scanner, you can use it for a file. So in this case, instead of asking the user for some keyboard input, I can ask the file, do you have a next token for me? If there is a token, then this method, all it does is prints it to the screen. So we'll take a look at this kind of an example. So what I'll do is I'll go into my directory here. What was the name of it here? Files. And I'll put a file that will pump it out to the screen so you can see it actually doing that read. So just a test document. So I'll go A, B, C, 1, 2, 3, hello, world. There. Okay, so that's the contents of this file. Now we'll talk about how do you go into this file here. So as I said, the first thing you're going to need to do is go get your classes for input and for the utilities. So up top here, you can look up specific classes if you want to see which ones you're going to be using here, but we're going to use several of them, so that's just convenient. And the utilities package has the PrintWriter and the scanner that we're going to use. Lots of good stuff in there, so we'll just star it to use all of them. Okay. So basically the construct here, now I'm ready to show you in NetBeans how I can get it, is that I'm going to build a file and then try to construct something that will read from the file. So maybe I'll call this one example. And it is test.text. So problems can happen if I start trying to use that file. So the try catch block needs to start here. And we're going to be very unsophisticated in dealing with this error. But it'll still give me something of information, but there's obviously better techniques here than because I haven't put a statement in where a try catch block is necessary. That's why it's barking at me right now, but that'll change real close here. So file reader, and I'm going to wrap it around that example file. The only reason we're doing this, and you can use that class directly, but the only reason we're doing it is to wrap it in a scanner. So that's where I'm going to now ask for a scanner just like you know, but instead of calling from system.in, you're going to call from this reader. So scanner input equals new scanner, and it reads from the file. Okay. So now all the methods you normally read from are there. So let's have a look at how we could do this. This is my favorite pattern of programming. It's probably the best for introductory programmers. It's a real simple format. Each line contains some form of data in some additional format, so it's handy to read a line and then parse the line. So this is what it would look like. While input dot has next line, I'm going to pull that line off of the file. So string line equals input dot next line. And then I'm going to now tokenize this string. You might remember when we did this before, where I'm going to ask for a string array, and the tokens will be contained in there. If I ask that line to be split, and oops, must have hit the enter key. I'm going to split it on my data, which is a tab. Okay, so my data is broken up by the tab character, so it reads one line and chucks each token from that separated by a tab into this array. So now what I'll do is I'll spit out the contents so you can see what was found. Okay, so tokens index n. I'll just print it like this. Maybe I'll change it to a comma. Okay, so let's have a look and see what happens here. It's always good measure to free up the resources when you're done. So, I'm sorry, reads, the name was reads the file. That basically just allows somebody else to go grab that file and not get an exception thrown if it was the case. But if I run this now, I've hard-coded in the name of the file. So here's the content that I plugged in. So you notice Java went in, grabbed the stuff that I typed, and as it found those tokens, it printed it out here for me. So it gets each line, and then this time it asks for the line and none is found, so the loop stops. Okay? Similarly, we can take data that we want to pump out and write it to a file. So this is just the basics of reading, and I would encourage you to look at what you already know about scanners to do it. But this is my favorite programming pattern as far as read a line, tokenize the line, and then start parsing your data, whatever you want to do with it. So I'll just do a multiplication table, but I'll pump it out to a file rather than the console. So we'll do a nested loop with that. But I'll bring up your PrintWriter. Okay. And the PrintWriter is going to mimic, there it is. It's going to mimic the way you normally would use system.out. So this way, what you know normally when you use system.out is going to be wrapped by the PrintWriter class. So if I go to my code here, this time I'm going to make a file writer. So the rule when you write to a file is you destroy it. So if you intend to change the file, your job is to read it first, save that data somewhere, or hold on to it in the dynamic memory of the computer, like non-persistent, not hard drive, then call it open for writing. So when you open it for writing, it's going to die, basically. Yeah. So the I'm going to change the name just because it'll destroy this file otherwise. So I'll just call it output. So now, because that file's not there, Java's going to go in and try to make that file for me. And I'm going to try to open a file writer. And I'll call it creates the file. And it's a PrintWriter that I'm using. So again, there are other ways of doing this, and I'll have to fix up some of my variable names there, of course. But the reason I picked these is they parallel stuff we've already done, and the PrintWriter is very close to system.out. So let's see here. This time, I don't need to check. I'm going to have to alter this loop. I'll get rid of this, but I might as well keep the part that closes it. This time, I don't need to check if there's data available in the loop. I'm pumping the data out myself. So that's what I'm going to do here is go for int n equals, let's start at 1, while n is less than or equal to 10, n plus plus. And I'm just going to make a simple times table here. Okay, so I'll write that in the file. So as you see, you got all kinds of different write methods that you can use. We're going to use the string one here. We're actually going to write a line of code. Print line, and I'm going to say this is a 10 by 10 multiplication table. So I'm going to build up the string and write it to the file, and this is what it'll look like. String line, there's nothing in it at the moment, And what I'll do is say line plus equals, and I'm going to type in n times k. Excuse me, that is the multiplication. And then I'll join it with the tab character to separate each one. So this will take each number, do the multiplication, and then I have to go to the next line here. So this is where I want the line to appear. So now I've moved that multiplication table down to the next line. And now I'm simply going to say to the file, print that line that I just constructed for you. The next time it goes in, the line starts fresh, creates the next line of data in the multiplication table, and prints it out. So sometimes you might be, maybe you've tested data and the screen just was too big to hold it on the console. Let's run this and see what we end up with here. So far that looked okay. Hopefully when I get here, there's a new file called output, and there's my multiplication table. So it pumped it out to the file instead. So for the beginnings of this, before we do tying it back into saving and loading your video game, I just have some basic exercises that I'd like you to practice to show me some fluency, okay? Rather than jump right into the deep end. So this file utility class is one way that I'd like you to show me that. And here's the methods that you would want to execute here. So for example, can you make me a file utility class, a full Java class that has these methods? You can read the definitions on your own time. And also, this is kind of a neat exercise to try, some basic encryption. So this is usually known as a Caesar cipher if you want to try encrypting. Don't spend much time on the math. I'm happy to help you with the math involved on this. But basically, if we were to make a secret message, we can try one right here just so you get the basic idea. So someone give me a single digit key.
What?
Single digit, like 1 to 9, a single digit key. 8, okay. So let's pick the word hello. So if the key is 8, the secret word is going to move these 8 positions. So H becomes IJKLMNOP. E becomes FGHIJKLM. Then L becomes MNOPQRST. And O is going to become PQRSTUVW. Okay? So this would be the secret word. Now, to somebody who doesn't think much of it, they might just think, oh, what is this garbage, data transmission error, or who knows. But to you, it's a secret word that you can create by telling the other person our secret key that we use is 8. So you can encrypt a whole file this way, rotating every character by 8 spaces. How do you get it back? Well, instead of rotating forwards, you rotate back. So you subtract it. I don't even know if I can do this here because my alphabet, can we go backwards here? It would go, let's try P. So it would go O, N, M, L, K, J, I, H. There we go. So I went backwards to undo it. Right? Forwards to encrypt it, backwards to undo the encryption. So that means we can recover the message. It's not good encryption if you can't recover the message. Every encryption has to be recoverable. It's just how hard it is to recover it makes its strength change. So what do you do with something like, for example, let's say we had Z and the key is 5. Anybody have any ideas?
What go into numbers?
In this,
Go to like
let's
A.
pretend it's only A to Z, okay? You're right, it's going to probably overflow into other characters that Java has, because Java has more than 26 characters, right? But I'm just saying, let's pretend it's A to Z. What do you think a reasonable thing to do with this is?
You can send it backwards, or
Well, you could send it backwards, but then you have 2 different rules. Like, how do you know to go forwards or backwards? That means for every letter you have, you'd have to test it once forwards and then backwards. So for every message you send, there'd be many, many different possibilities to decrypt it. So yes, that is recoverable, but there would be many, 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 many different ones. And the only way you would know it's correct is you'd have to check which one individually is coherent, which one actually makes sense as a word. So in this case, we go Z becomes A, then B, then C, then D, and it stops at E. So what happens is it rotates itself around. And the way you can think of that is that's like modulus counting when you use remainders. So for example, if the numbers were 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you said, oh no, this alphabet only has 4 characters, it should go like this: 0, 1, 2, 3, 0, 1, 2, 3, 0, 1. You just keep looping back around using modulus. So that's where the math is going to come into play here with pushing it forward and rotating it back. It's a bit of a remainder to help make that rotation happen. So in order to encrypt a file, for 8-bit characters, you'd have 256 values. You need to know about that 256 because that means when you tilt off the end, the 255th character will then go to 0 as it loops back around. Okay? So there is a little bit there in the encryption for you to look through in case that wasn't you want a little bit more of an explanation. Otherwise, this is the last thing I'm going to leave you with is the CSV file, because this is such a common format that I'd like you to have a bit of fluency with it. You will find it handy to use a CSV format with saving and loading your game. It's just a simple way of defining how your format of data is. So I'll come up with another short lesson for you guys where we will actually look at using CSV files to save and load the game. But we'll stop here. Those are the assignments I expect that you will complete to show me this basic literacy of reading and writing to and from disk. Okay?